In today's session, we are going to discuss a few questions on continuity and differentiability. We have discussed a lot of questions on limits already. So now we'll move on and discuss a few general questions that we have in continuity and differentiability, which will also be have some applications on limits involved, obviously. So let's begin. Question. If fx is defined as 1 by 1 minus x, then find the number of points of discontinuity in y is equal to f of 3n x, where f of n x is defined as f of f of fx taken n times. So to solve this, we first look at what would be the pattern for f of fx and so on and so forth. So if fx is this, we first start with f of fx. So this would be like a 1 by 1 minus 1 by 1 minus x, which when we simplify will give us 1 by 1 minus x minus 1 by 1 minus x, which is like writing a 1 minus x by minus x. Okay, or a x minus 1 by x. So that will be f of fx. Then we look at what happens to f of fx. If we do the composition again. Well, in a way, this can actually also be written as 1 minus 1 by x. So that will reduce the amount of calculation that we have to do in the next step. So this will be 1 minus 1 by 1 minus x. So this will end up becoming 1 minus 1 minus x, which is x. So f of fx, when we do the composition 3 times, we'll get x back. Okay. So every 3 compositions of x will give us a x back. And then in that case, when we do f of 4x, so it would again start with 1 minus x. फिर से यहाँ पे start होगा. So 4, 5 and 6 पे. It will again return to x. So the composition will have a cycle of 3. Okay. After every 3 consecutive compositions, the value will reduce to the values of compositions will repeat. F of 4 will be this. F of 5x would be 1 minus 1 by x. And f of 6x will come back to x. So in that case, at how many points will the function be non-differentiable or will be discontinuous? So f of 3nx over here will become y is equal to x. Okay. But it is defined as a composition. So in a composition, f of gx, if gx is discontinuous, the f of gx would also be discontinuous. So we look at this f of isme. If you look at fx, when is fx discontinuous?
One.
Fx is discontinuous at 1. And what about f of fx?
0.
F of fx would be discontinuous at x equal to 0. And f of fx,
No way.
the f over here is basically continuous.
Continuous.
क्योंकि वो तो y equal to x आ जाएगा, तो individually it will not have any discontinuity. Okay, this is, we are talking about individually. So now when we look at them as a composition, so what would be the points of number of points of discontinuities?
Three.
There will be 2 points of discontinuities at x equal to 0 and 1. Because although f of fx is continuous everywhere, but f of fx is discontinuous as 0, which will make the whole thing as discontinuous. The composition will be discontinuous. Fx is discontinuous at 1, so composition will be discontinuous. F of fx is discontinuous at 0, so composition will be discontinuous again. So that will be the answer. Discontinuous at 2 points, 0 and 1. Then question number 2. Fx is defined as the fractional part of x by 5 plus box of x by 2. Find the number of points at which fx is discontinuous in x going from 0 to 100.
फ्रैक्शनल पार्ट और बॉक्स एक्स है ना.
क्या?
फ्रैक्शनल पार्ट और बॉक्स एक्स है ना.
हाँ, fractional part in box x. We have a fractional part of x by 5 and box of x by 2. So over here we start with the knowledge that both the fractional part and box are discontinuous at all integers. At all integers, which means, well, for a general scenario, this would imply that where it would be discontinuous whenever the entity inside becomes an integer. Whenever the entity inside becomes an integer, the expression will be discontinuous. You know. So,
सर आंसर 10 है क्या?
hello?
सर आंसर 10 है क्या?
हाँ शुभम बोल, क्या हुआ?
सर आंसर 10 है क्या?
आंसर 10 एक बार चेक करते हैं यार. दिस जस्ट लेट मी डू दिस. हाँ शायद प्रॉब्ली 10 है. So what this would tell us is that for all x belonging to 0 to 100, at how many points will fractional part of, at how many points would x by 5 be an integer?
20.
70 points.
X by 5 will be an integer for all multiples of 5. How many multiples of 5 that we have?
20.
So for x
20.
belonging to 0, 5, 10 going up till 100, which would be 20 values. And x by 2 will be an integer for x belonging to 0 to 4 going up till 100 as well, which will give us 50 values. Okay, now. But then in that case, will the answer be 70? That this is discontinuous at 70 points? No, because if you notice between the set of the fractional part and the set of x by 2, there will be some common values present, जो obviously दो बार count नहीं करना है. ठीक है. So let's look at the set of common values.
And
So the common values would be when x
Even
belongs
multiples
to
of-
something like 0,
even multiples of 5.
10, 20, and so on and so forth up till 100. ठीक है ना? Okay. Now, the problem at these points would be that at this point, fractional part is discontinuous, box is discontinuous as well. Now, from algebra, the sum of two discontinuous functions may or may not be continuous. तो इन पे अलग से चेक करना रहेगा, बाकी पॉइंट्स पे चेक नहीं करना है. Like if you look at 5, fractional part at 5 would be discontinuous, but box at 5 is continuous. So the resultant will be discontinuous from algebra. But at 0, 10, 20, at these points, both the fractional part and the box will be discontinuous. So that will imply that we will have to check for them separately. As according to algebra, the sum of two discontinuous functions may or may not be discontinuous. So we look at x equal to 0. Okay, x equal to 0 is the starting point of the boundary. So यहाँ पे सिर्फ RHL और value of the function check करेंगे. So what would be the value of the function at 0? तो इसको 0 कर दिया. 0 by 5 is 0. Fractional part of 0 is 0. ये भी 0. So value of the function would be 0. And the right hand limit. So right hand limit is delta positive. Fractional part of delta positive भी 0 आएगा और delta positive box of delta positive भी 0 आएगा. So that means at 0, f is continuous. Then at x equal to 10, let's look at the left hand limit. So the value of x is slightly less than 10. So 10 by 5 हो जाएगा slightly less than 2. Limit x tending to 10 minus x by 5 plus box of x by 2. So little for a value little less than 10. X would be little less than 10. So 10 by 5 would be a little less than 2. Box of a little value little less than 2 is 1. And यहाँ पे होगा slightly less than 10 to slightly less than 5. So slightly less than 5 का box हो जाएगा 4. So the left hand limit would be 5. Okay. Now let's look at the right hand limit. So limit x tending to 10 plus fractional part of x plus 5 plus box of x by 2. Now x is slightly greater than 10. So 10 by 5 would be slightly greater than 2. The right hand limit of fractional part at 2 would be 0. And ये होगा slightly greater than 5 का box आ जाएगा 5. So the right hand limit is 5 as well. Okay, value of the function. So value of the function for the fractional part at x equal to 10, 10 by 5 is an integer, fractional part of an integer 0 plus 5 is 5. So the left hand limit is 5, right hand limit is 5, value of the function is also 5. So what can we say about x equal to 0?
Continuous.
The function
Continuous.
is continuous. Okay. So at all the common values, what will happen from here? What can we conclude for all common values?
Continuous.
Continuous.
The function will be continuous at all common values. The function is continuous at all common values. So which means then, how many points of discontinuity will we have? So in 20 values में से ये 11 values subtract हो गया. So this will leave us 9 values. And this will leave us with 39 values. So the number of points at which the function is discontinuous would be 39 plus 9. 48. The function is discontinuous at 48 values. Is everyone able to understand this? Okay, sorry, I made a mistake. 0 to 100, these would be 21 values. And 0 to 100, यहाँ पे भी ये 51 values होगा. And subtracting 11 from each will give us 10 values यहाँ पे, 40 values यहाँ पे, for a total of 50. The answer would be a number of points of discontinuity in the function would be 50. I forgot to include 0 in the upper values, the upper values. Was anyone able to understand this?
Yes. Sir.
Okay, next then. Question 3. If fx has an isolated point discontinuity at x equal to a, but mod of fx is continuous at x equal to a, then what must have happened? A, limit x tending to a fx doesn't exist. B, f of a is 0. Option C, limit x tending to a fx is minus of f of a. D, none. So the function has an isolated point discontinuity implies that the limit must exist. So LHL is equal to the RHL and f of A is somewhere else. You know. So graphically speaking, at x equal to A, let's suppose, the graph must be something of this form. Okay. Well, it doesn't necessarily have to be a continuous function, but I'm just saying that ऐसा कुछ होना चाहिए. Okay. Which is like if this value is f of A, then this value must be a minus of f of A, so that when we do the mod transformation, what would happen in this case when we do the mod transformation? The graph will become complete and be continuous. Okay. So for this thing to happen, limit of f of x as x tends to A must be equal to minus of f of A, so that when we take the mod after reflection, the entire graph will club together. Is anyone able to understand this? So for mod fx to be continuous, limit of x tending to A of x must be minus of fx, minus of f of A. So that after reflection of the mod, the graph is completed. Next question. If fx is defined as अरे चलो पहले पूरा कहानी लिखते हैं उसके बाद ये करते हैं. That's a very interesting question that we are going to do next. Let the equations x cube plus 2x square plus px plus q equal to 0 and x cube plus x square plus px plus r equal to 0 have two common roots and the third roots are given by alpha and beta. Okay, the third roots are given by alpha and beta. Now, we have a function fx which is defined as e to the power x into ln of mod of alpha plus beta to the base 1 plus x. Oh, sorry, ln नहीं होगा, log होगा. X into log of mod of alpha plus beta to the base 1 plus x for x less than 0, a for x equal to 0, and b times log of e to the power x square plus alpha beta times root x by tan of root x greater than 0 is a continuous function. Then find a alpha square plus beta square, b a plus b, and c या चलो ये दो ही निकालो. Find the value of alpha square plus beta square and find the value of a plus b. So advanced level question है. Let's try it out. Okay, let's discuss the solution for this. So the solution of this will go something like this. Let the common roots be m and n. Okay. Let the common roots of the two equations be m and n. So this would imply that for the first cubic, the roots are m, n, and alpha. For the second cubic, the roots are m, n, and beta. Okay. So which then accordingly from the properties that we have done in cubics, the various relations that we get in this case would be m plus n plus alpha is equal to -2, mn plus m alpha plus n alpha is p, and mn alpha is q. Similarly, m plus n plus beta would be -1, m plus sorry, and the next relation would be mn plus m beta plus n beta is p, and mn beta is r. ये relations आएगा. Okay. Now let's say we take this as equation 1, this as equation 2, and subtract 1 minus 2. So mn cancel ho gaya, we'll have alpha minus beta is -2 plus 1. Alpha minus beta is -1. And if you look at the second equations, isko bhi subtract kar do. Let's say this is equation 3, this is equation 4, and we subtract them as well. 3 minus 4, right? So it will be like alpha times m plus n plus minus beta times m plus n is equal to 0, or that is like alpha minus beta times m plus n is equal to 0. But alpha minus beta is, we have already established, is -1. But a product of two factors is 0. So either of them must be 0. But alpha minus beta is not 0 because it is -1. Therefore, what must be 0?
M plus N.
M plus N.
So m plus n is 0. ठीक है ना? But then if m plus n is 0, so what would be alpha?
-2.
Alpha हो गया -2, beta हो गया -1.
-1.
Is everyone clear on the calculation of alpha and beta? Is it okay with everyone?
Yes, sir.
Okay. So alpha beta आ गया. So alpha square plus beta square would be like a 4 plus 1. So this would be 5. Now for a plus b, we'll have to go for limits and continuity. ये इसमें लगेगा a and b के calculation में. So considering that alpha is -2 and beta is -1. So fx now, if we plug in all the values, would be like e to the power x into log of mod of alpha plus beta. So -2 -1. So ये हो गया 3. 1 plus x for x less than 0. A for x equal to 0. And then we have b times log of e to the power x square plus alpha beta. So alpha beta is 2 root x by tan root x for x greater than 0. ठीक है ना? Now considering it continuous है, so LHL is equal to RHL is equal to value of the function करना है. So let's begin with LHL. What be LHL in this case? So that will be limit x tending to 0 minus e to the power x into log 3 1 plus x. Now how do we calculate this? So this will be like writing x into थोड़ा base change लगा दो. So ln 3 by ln of 1 plus x
Is 3.
limit x tending to 0 minus. But in that case, this x from here can be shifted to here, and log of 1 plus x by x as x tends to 0 value
1.
1.
हो गया 1. So we are left with e to the power ln 3,
3.
which is 3. So the left hand limit would be 3. Now for continuity in that case, what must be the value of the function?
3.
3.
So a का value तो 3 आ जाएगा. And now we check for the right hand limit. So limit x tending to 0 plus b times log of e to the power x square plus 2 root x by tan root x. Now let's check the form of this as x tends to 0. What's the form over here?
Infinity by infinity.
So well, either you can apply L'Hopital in this, या फिर L'Hopital में differentiation अगर थोड़ा सा complicated हो जाएगा, तो we can do this as well. Limit x tending to 0 plus b times ln of e to the power x square common ले लो. So we'll have a 1 plus 2 root x by e power x square divided by tan root x. Okay. Now this is a log of a plus b, so we'll end up becoming limit x tending to 0 ln of e to the power x square plus ln of 1 plus 2 root x by e power x square whole divided by tan root x. Okay. अब इसमें ln of e to the power x square हो गया x square. So we'll get x square by tan root x plus ln of 1 plus 2 root x by e power x square by tan root x. Okay. Now tan root x के लिए what we do is इसको 3/2 करके shift a root x यहाँ पे. So in that case, what will happen to tan root x by root x? ये 1 हो जाएगा.
1.
And x का वैल्यू 0 है. So the first limit is set. ठीक है, फर्स्ट लिमिट सेट है. अब सिर्फ सेकंड लिमिट का देखना है. So let's look at the second limit. यहाँ पे अलग से सॉल्व कर लेते हैं इसको. So we have x tending to 0 plus. अच्छा, ln of 1 plus something. How do we create the standard form? By that
1
something
plus x by x.
Into the sum.
into that something. So 2 root x by e power x square and into अपने पास एक tan root x है. So over here then what should be our next step?
Multiplying and divide by
Can we
2
just
root x
pair
by
this
3
root
pi.
x जो अपने पास
रूट
ऑलरेडी
एक्स को
है
नीचे भेज देंगे.
यहाँ पे? रूट एक्स तो अपने पास ऑलरेडी आ रहा है ना यहाँ से. 2 root x का रूट एक्स यहाँ पे शिफ्ट कर दो. So root x by tan root x 1 ln of 1 plus something by that something as the something tends to 0 1 and ये कितना आ जाएगा? e power x square as x tends to 0 1 as well.
1.
ठीक है. अच्छा b भी तो था यहाँ पे पूरे में. b बाहर कर दो. b into. So this would be b into पहला लिमिट का वैल्यू 0, दूसरे लिमिट का वैल्यू 2. So 2b. But then for continuity, what should 2b then be equal to?
A.
A 3.
So for continuity, 2b must be equal to 3. Therefore, we get b as 3/2. Was everyone able to understand this question?
Yes, sir.
Yes.
ठीक है. काफी इंटरेस्टिंग क्वेश्चन है ये कंटिन्यूटी का. It's an advanced level question. So please make sure that you understand this. We have a separate process to find alpha beta and then a separate process for finding a and b. Okay. Next question. Discuss differentiability of fx equal to root over of 1 minus root over of 1 minus x square at x equal to 0. Again, now the reason we discuss this question is, well, we are asked to discuss differentiability of this. Now, if we try to differentiate this directly, f dash x. So f dash x would be 1 by 2 root over of 1 minus root over of 1 minus x square into फिर minus root अंदर वाली root का derivative आएगा, so we'll have a minus 1 by 2 root over of 1 minus x square and फिर अंदर वाली 1 minus x square का derivative आएगा, so that will be like a minus 2x. तो ये इधर cancel हो गया, 1 2 cancel हो गया. We'll end up getting 2 root over of 1 minus root over of 1 minus x square into 1 by root over of 1 minus x square and ऊपर में x आ जाएगा and in the numerator. Isn't clear on the derivative?
Yes, sir.
Now, if you plug in x equal to 0 in this, what do we get? So at x equal to 0, this would be 0, पर ये वाला entity भी 0 हो जाएगा. So the denominator is becoming 0, which means f dash x doesn't exist. Okay, f dash x is not defined. Or f dash x nahi, in fact, not f dash x, rather f dash 0 is not defined. So can we say that but does that matter? F dash 0 not defined, does that affect differentiability? I hope you remember that we had discussed it in class that for a function to be differentiable, f dash a doesn't matter. What matters is the limit of fx, limit of f dash. If the limit of f dash exists, then the function is differentiable. It exists and equal, then the function is differentiable. If the limit exists, then it is differentiable. If the limit doesn't exist, then it is not differentiable. Whether f dash a is there or not doesn't matter. Okay, now. So what we do is we solve this with the LHL RHL method. So LHL, limit h tending to 0 minus, ये हो जाएगा root over of 1 minus root over of 1 minus h square minus f of 0, which is 0, divided by minus h. Now, इसको solve करने के लिए we rationalize by minus h multiplied with root over of 1 plus root over of 1 minus h square divided by root over of 1 plus root over of 1 minus h square. So this will end up becoming root के अंदर 1 minus 1 plus h square divided by minus h into root over of 1 plus root over of 1 minus h square. तो इसमें 1 1 कैंसिल हो गया, रूट कैंसिल होके कंसिडरिंग दैट h इज पॉजिटिव एनीवेज, सो ये आ जाएगा h mod h by minus h into root over of 1 plus root over of 1 minus h square. Okay, but h is always positive. h tending to 0 minus h हो गया ना, 0 minus नहीं होता. h तो हमेशा पॉजिटिव है, so the mod doesn't matter in this case, वो h ही हो जाएगा since h by definition is always positive. So इससे वैल्यू क्या आएगा? अच्छा लिमिट भी तो है भाई, लिमिट h टेंडिंग टू 0, लिमिट h टेंडिंग टू 0, लिमिट h टेंडिंग टू 0, तो h 0 है, यहाँ पे 0 डाल दिया, ये आ जाएगा -1/√2.
-1/√2.
एंड सेम वे में RHS भी सॉल्व करेंगे. So RHL would be limit h tending to 0, root over of 1 minus root over of 1 minus h square minus 0 by h. तो ये पूरा सेम वे में सॉल्व करके फाइनल लिमिट आएगा लिमिट h टेंडिंग टू 0, h by h into root over of 1 plus root over of 1 minus h square. तो ये h कैंसिल हो जाएगा, इस केस में we'll get the value as 1/√2. So we have the left hand derivative is not equal to the right hand derivative. Therefore, the function is discontinuous. Non-differentiable. The function is non-differentiable. Okay, moving on. I hope everyone's okay with the question. Next question, an application question on differentiability. If a function defined as mod of mod x minus 2 mod of mod x minus 2 plus p. Fx is defined as this mod of mod x minus mod x minus 2 plus p. If f has exactly 3 points of non-differentiability, then find p. If f has exactly 3 points of non-differentiability, then find p. It's a graphical question है, application. Okay, graphically सोचो, what will the graph of mod x? So mod x is a v, mod x minus 2. तो mod का ग्राफ shifted 2 unit downwards.
Shifted 2 units downwards.
ठीक है, so mod का ग्राफ shifted 2 unit downwards. फिर वापस mod हो गया. So that would be mod का ग्राफ, everything below the x-axis reflected above the x-axis. ठीक है, ये हो गया. Now when we do P plus P, so if P is positive, what will happen to the graph? It will move upwards.
Upward.
And if P is negative, then the graph will move downwards. ठीक है ना?
पापा मैं गोलू के साथ खेल रहा था मैं थक गया हूँ और वो सोने गया तो मैंने उसकी आखिरी बार फोन देखी उस
Now, if you look at the graph at this juncture, how many points of non-differentiability does it have?
3.
The current graph is already non-differentiable at 3 points because we have 3 corners already, 1, 2 and 3. So now, and the question needs it to be this, so we basically have to maintain the status quo. So what value of P will ensure that no further points of non-differentiabilities are introduced? For no more. So for no further points of differentiability, P must be greater than equal to 0. Because if P is anything less than 0, so graph हो जाएगा something like this. Depending on the magnitude. And फिर जब वापस से mod करेंगे, तो then the graph would be something like this. We'll have 1, 2, 3, 4, 5, and then another one like this. इतना points of differentiabilities आ जाएगा. Is everyone okay with this part? So if we had to discuss this question out for all possible scenarios, so all possible scenarios may it will be like if P is greater than equal to 0, then the number of points of differentiabilities would be 3. ठीक है ना? If P is if P lies between -2 to 0, तो ये situation होगा. So in that case, the number of points of non-differentiabilities would be 1, 2, 3, 4, 5, 6, 7. Non-differentiable at 7 points. Okay, we are discussing the entire scenario, all possible scenarios, although we had to do the question for this. अच्छा, if P is equal to -2, तो क्या होगा? Then the graph would be something like this, which when we do the mod transformation,
5 पॉइंट आ जाएगा.
will end up becoming something of this form. So 1, 2, 3, 4, 5. We'll have 5 points of non-differentiability. And if P is less than -2, then the graph will go further down. Which on mod transformation will then look something of this form. So इस case में भी we have 1, 2, 3, 4, 5 points of non-differentiability. Is everyone able to understand the entire question? Okay. If P is greater than equal to 0, 3 points of non-differentiability. If P lies between -2 to 0, 7 points of non-differentiability. And if P is less than equal to -2, then we have 5 points of differentiability, non-differentiability. Does everyone get this? To try out a similar question just to ensure that the point has been understood. Question. If fx is defined as mod of x square minus 10x plus 21 minus p has exactly 6 points of non-differentiability. Find p. Find the values of p for which the function will have exactly 6 points of non-differentiability. Answer, anyone?
0 to 4.
So x square minus 10x plus 21 would be an upward opening parabola with roots at 3 and 7. So we'll have the graph of it, something like this. An upward opening parabola with roots 3 and 7. And what is the minimum value of this function? Five, 3 and 7.
X equals 5.
5 पे होगा 25 plus 21 46 and minus 50 तो minus 4 होगा इसका minimum value. Okay. Now इसका mod कर देंगे. So mod करने पे this part would be deleted and ये आ जाएगा ऊपर reflected like this, which will create 2 points of non-differentiability. Now we have a minus p. Okay. And ये वाला जो टिप है ये आ जाएगा अभी 4 पे. So इसमें 3 केसेस बनेंगे again. If p is greater than 0, p lies between, अच्छा यहाँ पे minus p करना है. So the cases will change accordingly क्योंकि minus p कर रहे हैं. तो 3 cases over here would be p less than 0, p lying between 0 to 4, and p greater than 4, greater than equal to 4. So if p is less than 0, तो minus of p will become positive, graph ऊपर चला जाएगा, and graph ऊपर अगर गया तो it will continue having 2 points of non-differentiability. If p lies between 0 to 4, तो ये वाला केस तो ये वाला केस होगा, the graph goes down and will become something like this. Which when we do the mod transformation will end up becoming something of this form. एक ये ऐसा कुछ ग्राफ आ जाएगा, which will create 1, 2,
6 points.
3, 4, 5, 6 points of non-differentiability. Yeah. And if p is greater than equal to 4, then the graph will shift like this. And then the mod transformation of this. Mod transformation of this would be again something of this form. This. ये थोड़ा बैटमैन का ऊपर वाला पार्ट बन जाएगा. So now this function is non-differentiable at 4 points. So that will be the description for this. 4 points at which the function is non-differentiable, but in the question we are asked to do it for 6 points. So for 6 points, the answer is P has to lie between 0 and 4. P has to lie between 0 and 4. That will be the answer. Okay, next question. It's a very common question that we have for continuity and differentiability. And it's a kind of a result that you have to remember as well. Let's say if fx is x bar p sine of 1 by x for x not equal to 0 and 0 when x is equal to 0. Find p for f to be continuous. First case में continuous, second case में differentiable. What should be the value of p for f to be continuous and to be differentiable? So we do for the first part, continuity. So continuity के लिए the left hand limit of this would be limit x tending to 0 minus x to the power p sine of 1 by x. And this has to be 0 because the value of the function to 0 hai. Now, how do we ensure that the limit x tending to 0 minus x power p sine of 1 by x is 0? So sine of 1 by x as x tends to 0, 1 by x will be infinity, sine infinity ho gaya. And sine infinity is the case of a discontinuous function. Okay, oscillating discontinuity hai. And x power p is a continuous function. So if you remember algebra, for the product of a continuous function and a discontinuous function to be continuous, the value of the continuous function must be 0. So x power p 0 होना चाहिए. But when will x power p be 0? When will limit x tending to 0 x power p be 0? When p is greater than 0. X has to stay in the numerator. If p negative हो गया, x denominator में चला गया, तो the value will tend to infinity, not 0. So p has to be greater than 0. Okay. So this will tell us that fx will be continuous if p is greater than 0. ये है condition of continuity, p greater than 0. And then we look for differentiability. So differentiability में left hand derivative because it's a piece removable discontinuity का case है, direct differentiation नहीं होगा. So we look at the left hand derivative. So f dash 0 minus would be limit h tending to 0 f of h. So h power p sine of 1 by h into f of 0 which is h. अब तो 0 है ये तो h हो गया. So this will become limit h tending to 0 h to the power p minus 1 into sine of 1 by h. अब फिर से वही बात आ जाएगा that we did over here. Sine of 1 by h is a case of oscillating discontinuity. Which means this value will only exist if limit h tending to 0 h power p minus 1 is 0. But this will happen when p minus 1 is greater than 0, so that h stays in the numerator, which implies p is greater than 1. Okay. So for differentiability, p has to be greater than 1. So continuity के लिए p has to be greater than 0. Differentiability के लिए p has to be greater than 1. So if p lies between 0 and 1, result क्या आएगा? Continuous but not differentiable. Clear है? Okay, we'll stop at this for today. Right?